And so it is. All right, welcome to Mod 1 Overview. So we started doing these about a year ago after it became clear that all these little pieces that we learn along the way in Mod 1, it's very difficult to see how they fit into a bigger picture because they're very discrete and isolated. It's hard to think about how you might even like make an app or something around that kind of thing. So this is not a lesson, which means you should not be able to do anything different by the end of this. I don't expect that you'll be able to do almost anything that we're going to cover in this, but hopefully this gives you a roadmap for what the next 2 weeks sort of look like. So it's not something you need to take notes on. It's not something you need to code along with. We will have things like that today even, but this is not one of those things. So let's take a look at the standards for Mod 1. All right, so these are the things that I think you should be able to do by the end of this mod. This first one, demonstrating basic programming proficiency in Java and Ruby, that's stuff that we do all over the place. And so what we're talking about with that is things like, pull up a file. All right, so if I make a Ruby file, I should be able to do things like puts 1 + 1, and then I should be able to run that file and see the result. I should be comfortable with things like if statements. I should be comfortable with some looping constructs, variables, some of the like vocabulary. Hashcabal, like everything we do in Hashcabal, I would classify as part of this. It's an important building block, but mostly so that we can get to class syntax and enumerables. So let's talk about like an actual problem we might have. So let's say you have a dog you've got an owner, and we want to show which dogs belong to which owners and which owners have which dogs. So you could say that one dog one owner has many dogs, and each dog only has one owner. So if I have a dog named Bixby, then we say that Bixby is one of my dogs, and I am Bixby's owner. I might also have a dog named Mesa. And so I own both of these dogs, but both of them are owned by me, and they can't have more than one owner. So this is what we would call a one-to-many relationship. But the challenge with this is that I'm married. My wife owns the dogs too. So really what we want to be able to see is like, all right, well, Mesa is owned by Kyle and Elise. And Bixby is also owned by Kyle and Elise. But not every dog needs to be owned by both of us. Dog could have one owner, could have 30 owners. So that becomes a many-to-many relationship. And that's the thing that we're going to try to represent in code in this module. Most of the stuff we're doing is kind of in service of that. By the way, this exercise that I just did with drawing those little scratches, they're called crow's feet. That is modeling domains using ERDs. If I wanted to model that in code, it might look something more like this. All right, so I got nothing in this folder. I make an owner.rb file, and I make a dog.rb file. When we have like these concrete like nouns like this, we often try to represent those as classes. We'll talk an awful lot about classes this mod, but TLDR, they're like cookie cutters for making cookies. So we'll say a class is a cookie cutter and an object is a cookie. So I want to be able to make owners, and I want to be able to make dogs. And then I got to have something that I'm actually running in this app. So I'm going to make an environment.rb file. So I have these 3 files in this folder, and I can pull those files into this file. So I could say something like require dog and require owner. And hopefully you all have been starting to get familiar with a tool called Pry. We're actually going to use that to run our app. All right, so if I run this file with Ruby, I should be in this Pry, and I should have these 2 classes available. Let's see if I'm right. All right, so I'm in there. I can do something like Bixby is a new dog. Hey! I can say that Mesa is a new dog. Hey! I can say that Kyle is a new owner. So that's how we're starting to model this problem with code. So we're not saying anything about the relationship just yet, but I can make instances of dog and owner here. So what if, go ahead.
Why is that separated into multiple files instead of all in one file?
So we totally could. I mean, especially right now, I could go over to this environment RB file. I can paste this over here. I could paste this over here, and this does the exact same thing. What happens when I get 3 classes? What happens when I get 30 classes? What happens when I get 300 classes? What happens when I get 3,000 classes? So we start breaking this stuff out to make things, so as they grow, it becomes easier to find stuff.
Okay.
Good question.
Thank you.
Also, a quick note, this text editor that I'm using here is called Vim. You'll see me use it a lot in this program. It's exactly like VS Code. Does all of the same things. It just runs in your command line instead of, oops, hang on. Do not disturb. It just runs on your command line instead of on your desktop. It is crazy fast. It has tons of benefits to it. It's another one of these like, yeah, this looks like it's 50 years old. It is. But it's stuck around for 50 years because it is the most lightning fast text editor there is. Should you be learning Vim right now? Probably not. I imagine you have better uses of your time in these next 15 weeks than picking up Vim. But if I'm unable to talk you out of it, there's usually about 1 every other cohort or so that really wants to dive into Vim. I got some resources for you. But everybody else, you're perfectly fine with VS Code. As a quick tour, these tabs up here are exactly like tabs in any other text editor. They're just the names of the files. Sometimes you'll see these numbers on the side and they kind of look confusing. They're called relative numbers. So the line that I'm on right now is 3, and then there's 1 up, 1 down, 2 down, 2 up, 3 down. I can also turn on absolute numbers. We can see just 1, 2, 3, 4, 5, 6. So it's a thing you'll get used to very quickly, but it takes out some of the noise of of a more graphic-based text editor. All right. So I can also do some other things with these classes. So I could say whenever I make a new owner, I want to take in a name and say that, and save that name on the object that I just made. So what that looks like is, all right, I go, Kyle is a new owner. Says, hey, I was expecting you to give me something and you didn't give it to me. All right, fine then. So now I have an instance of owner that's keeping track of my name. Now, if I want to read that name, hey, Kyle, what's your name? Goes, I don't have anything that can give you the name. So we can say, all right, I want a method named name that all it does is return the name. I could write that like that, or return is automatically added to the last line of every method in Ruby. So I can just do that. And now when I try running this, I can make my Kyle instance and say, hey, Kyle, what's your name? And I get something back. And lastly, this is a common enough pattern that we actually have a shorthand for it. And it looks like that. This is a method, and we're passing in the symbol name, and it will just poop back whatever we're storing as name in there. And does it still work? By Jove, it still works.
So with that, did you need the semicolon there in front of it to define it?
The colon?
Or colon, yeah, sorry.
Yes.
Okay.
It takes in whatever thing you're trying to read out of it as a symbol.
Okay.
And so those kinds of things are examples of building classes and objects using Ruby. Really that easy. Cool. So let's see if we can see what's going on with these relationships here. So if I wanted to go back to our first one where I just said, all right, an owner can have many dogs. Each dog only has one owner. Let's take a look at how I might do that. So I maybe have something that's called something like add dog, and it takes in a dog. And dogs starts as an empty array. And then for every time this add dog method gets called, I shovel that dog into it. It's a little grim, but I didn't invent the terminology. So we shovel the dog into the dogs array. And then I should also be able to read a list of my dogs. So this might work something like this. All right, so I'm gonna make Kyle, I'm gonna make Bixby, I'm gonna make Mesa. All right, so I've got these three objects, and on Kyle, I can call add dog and pass in Bixby. All right, I can say, hey, can I add Mesa too? Hey Kyle, who are your dogs? And there we are. So I have created this one-to-many relationship. Now the challenge with this is it's hard to go, hey, Bixby, here I am. Who's your owner? Womp, 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 womp. Bixby can't tell who his owner is. Can anybody think of like logically how I might solve that?
Mm,
I can get Kyle's dogs. How do I get Bixby's owner?
Weren't you supposed to return the name of your dogs, Bixby and Mesa, after line 6 here?
I'm returning the instances of the dogs, not their names.
Okay, interesting.
So I made this new dog here. I made this new dog here. That's not their names. These are just variables.
Right, okay.
I'm not storing the name of the dog at all right now.
So
Okay,
instead
gotcha.
of asking the dog who owns it,
Mhm.
would you like put the question to all the owners? Say, which of you owners owns Bixby?
Ooh, fascinating. Let's try it. Typically do that.
I don't know if I feel confident about your reaction.
No, that's a clever way to do it. So I could say, who owns, and take in a dog, but I wouldn't do this with Kyle.
No.
I wouldn't say, hey, Kyle, who owns this dog? I do this with all owners. That's called a class method. I say, hey, owner, the owner class, who's got this dog? Okay. And so then I want to be able to iterate through all of the owners and find the first one that has that dog, right? So now I need to be able to iterate through all the owners. That's what I do there. Is I make this thing called a class variable. And every time I make a new owner, I shovel that owner into @all. Notice the 2 ats instead of the 1. All right, you're making Kyle right now. Make sure Kyle ends up in this array right there. And then I can ask owner, who owns this? And I can say, well, let me look through this and find the first owner where, what's the, like, you don't need to know the syntax. What's the logical thing that we're trying to do here, though?
see if the name matches.
See if the name matches? Ooh, not quite. Remember, the dog doesn't even have a name right now.
The instance, I guess.
The instance. We're trying to find out if the instance matches. How do we do that?
The dog is exactly equal to the dog. Return it. I don't know.
So
Exactly equal to
exactly equal to what?
owner.
So the dog is never going to equal the owner. But
Right.
the owner has a list of dogs, and I have this owner here.
Oh, right.
I have this dog here. How do I use those 2 things to figure out whether the owner has this dog?
We do owner.each.
Owner.each. I can only each over things that are arrays or hashes.
Oh.
What am I trying to each over? The owners.
The dog.
The
Their dogs.
dogs. Plural. That owner's dogs. So I could each over those. And maybe I could do something like for each owner dog. I got to give it a different name because I used dog up here. So I'm going through each of a particular owner's dogs. How do I know whether or not the dog that I passed in is in there?
If the dog's name that you passed in is equal to the dog's name that we're
The-
looking at in the loop.
Hey, that's the right logic. But remember, this is huge. It's going to take us a while to like get this down. It's not the name, it's the instance. So you are not your name. You're your passions and your interests and your soul and all of these different things, right? You have a name right now. You could have had a different name before. You might have a different name in the future. That can change. Who you are doesn't change. So it is with objects as well. But I want to see if the owner dog is the same as the dog that I was given, then what?
And return it, and then return.
Then return that dog? So part of the challenge here,
Return the owner.
and then return that owner. So what we're trying to do here is we're trying to find the owner. So what we're ultimately trying to do out of this is return true or false. And so we could say something like, oh man, that's hard. If we're in who. So I imagine you saw an awful lot of eaches in your Haskell review this morning. We actually have some more specific tools that might help us out in here. Because really, I want to like return whether or not the dog is in this like owner.dogs thing. I've got a more specific
Just a
tool.
true or false to return a Boolean.
Yeah, I'm trying to return a Boolean. I've actually got a better way to do that. I could say include. Does owner.dogs include dog? So that's going to return true or false for every owner that we go through. And the first one that it returns true for is going to come back from this find. And now we know who owns that dog. Let's see if it works. So I'm tired of typing these all out every time. So I can go back over to this environment file and I can put this stuff in there. And it'll be ready for me whenever that binding.pry runs. So I can say Kyle is owner.new Kyle. I can say Bixby is dog.new. Mesa is dog.new. I can say Kyle.add add dog Bixby, Mesa, and just for the walls, let's throw Elise in there. And Elise has a dog named Harmony. Cool. So this is my setup. It's ready whenever I run that file. If I run ruby environment.rb, didn't like something I just did. It's because I gave Elise the same variable name. That doesn't help. All right. So do these things still exist? Hey, there's Kyle. There's my dogs. There's Elise. There's her dog. So I can say owner dot, anybody remember what I called that method?
Owner.dogs.
The one to find.
I thought it was who owns.
Who
Who
owns?
owns?
That sounds right.
Yeah.
Let's take a look on this list. Who owns? There we go. So I can say owner dot who owns Bixby. Hey, there's me. There's Kyle. I could even say, hey, who owns Bixby? And what's their name? Oh, it's just Kyle. That's who. Who owns Harmony? Hey! So this is playing around with classes and objects. There's one other thing you got to be pretty solid on by the end of next week. This is the toughie. Is representing this from both directions. The way that we do this in programming, this isn't even a Ruby thing, this is just a general programming thing, is you represent these many-to-many relationships with a third thing in the middle. So you say that a dog has many dog owners, and each owner has many dog owners. This is called a join table. The only job of this join table is keeping track of which dogs are currently paired with which owners. So this is how I'm going to say that Kyle and Elise both own Bixby. It's very difficult to do that the way we structured this so far. So let's clean some stuff up.
A quick question. What is self?
That is a question for the ages, my friend. So we'll get into it more when we do some lessons on classes and objects, but when we're making a new instance of a class, self is that new instance that we're making.
Okay.
If we're not in the process of doing that, it refers to the actual class itself, which like in this case is owner.
Oh, is that similar to when you're using this keyword in JavaScript, like you're trying to classify, like referencing that specific object?
Yes. Those are the exact same idea. JavaScript does it in a way more complicated way.
Okay.
The Ruby one's pretty easy.
Okay.
Cool. So got the dog, got the owner. So I need another class. Touch dog owner.rb. Class dog owner. Cool. And check this out. I think this logic is pretty clever. I didn't come up with it, so but I do think that this is kind of a neat thing. So let's say I take this. I'm keeping track of every dog owner that I make. And whenever I make a new dog owner, I need to take in the dog and the owner. And I save the dog. I save the owner. And then I shovel myself into that add all array. Cool. So now what I'm doing, when I'm adding a dog, I'm really just creating a new record, a new instance of dog owner. So I can say something like dog owner dot new. I'll give you the dog because I just got given I was given the dog. How do I get who the owner is for that?
Self.
Self, it's me. And I pass myself in as the other argument. Okay, all right. So I could really do the same thing with dog too. If I want something that's like add owner, it takes in an owner. I could make a new instance of dog owner. It's going to take in me as the first argument, and the owner is the second. So I can add a dog from the owner class. I can add a dog, or add an owner from the dog class. Both of them, all they're doing is creating new instances over here. Here's where this gets wild. If I want to get all of my dogs, what I want to do is I want to iterate through every dog owner and find just the ones where I'm the owner. So I'm going to return that there so I have an all method. And over here I can say all dog owners is dog owner dot all. Cool. All my dog owner instances is all dog owners select and select is going to take a list of things and make it a smaller list, potentially smaller list based on some criteria. So I can say dog owner dot owner is me. That should be all of my dog owner instances. And then if I want all the dogs from that, I can say all my dog owner instances dot map. That's another select and map. We can do these things with each, but it's exhausting. We have more specific tools for this. Map is taking a list of things and turning it into a different list of things. Same length, you're just transforming it somehow. So I can say, I want to take each of those dog owners and only get the dog out of it. Then I end up with all my dogs. And if I return all my dogs, I should get an array of only my dogs. Let's see if it works. Yep, something I didn't like. Uninitialized constant dog owner. Oh, I know why. Anybody else know why? Why'd I get that error? What's the error telling me?
You haven't defined.
It doesn't know what dog owner is.
Right.
Why?
You haven't defined it? You haven't set it?
But it's, I see it right there.
Because you have that one was a symbol.
You got to require it.
I gotta require it. There we go. All right, let's try it now. All right. Hey, Kyle, who are your dogs? Whoop. Ah, undefined method owner. So what that means, I'm trying to read these two things out. I don't have methods to read those. Anybody remember what I did in the other ones to get those? I gotta say what I can read. All right, let's try it again. Hey, Kyle, who are your dogs? Damn, I'll bet that's Bixby and Mesa. Hey, Elise, who are your dogs? I'll bet that's Harmony. Pretty cool. So now I could do something like, all right, whenever I make a new dog, you got to give him a name. Got to be able to read the name. All right. So now we're making these guys over here. We can give them some strings that have their names. All right. If I run that same code again. Hey, Kyle, who are your dogs? Oh, just Bixby and Mesa. Elise, who are your dogs? Oh, just Harmony. And I can do this the other way around too. So I was doing all of this from owner. I can reverse pretty much this entire logic and do the same thing from the dog class and get my owners. I get every dog owner. I want only the ones where the dog is me. If I want all of my owners, I'm going to take all my dog owner instances and return the owner and return all that back. So now, let's say Elise also gets Bixby. So I own Bixby and Elise owns Bixby. Run the file. Kyle, who are your dogs? Oh, these two. Elise, who are your dogs? Oh, these two. Hey, Bixby, who are your owners? These two. Mesa, who are your owners? Just Kyle. That's how we program, that's how we represent this problem in code. So you can imagine all kinds of things that we would need to do with this. Rating systems. I mean, shit, even just the little dog and owner thing. It's a pet adoption agency. This is step one. This is how we're going to use computers to like store and work with this data. So again, you shouldn't be able to do any of this right now. If you can already, I don't know, probably signed up for the wrong program. But this is where we're going. This is where I hope you'll be able to do confidently by the end of next week. So ask me some questions about it.
Maybe not necessarily what you just did, but with the pry.
Yeah.
When you can use pry to assign values to variables.
Absolutely.
Okay.
Now the rub on that is they go away as soon as you're done.
Okay. That's
So,
okay.
like if I go in there and I go, cool, A equals 2 and B equals 4, I can get those values back all the live long day. As soon as I kill the program and run it again, they're gone.
Okay. Gotcha.
So you're using pry in the same way that you would use like an IRB then?
Exactly.
Could you like print the all array so we can see what that looks like?
Sure. So dog owner dot all looks like that. It's every instance of a dog and an owner at the same time.
And that all array is only inside the dog owner class?
Correct. Every time we make a new instance of it, that new instance gets shoveled into this all method.
So you would only make it in your join table?
Correct.
Okay.
I mean, you can make them anywhere. You can get a list of every dog that's ever been made, but this is the practical use for that.
Right.
Could you like name a couple other real world applications of this? Like you said, like a rating system, like what else would this look like in an actual application?
Students and classes. You can have many classes. Each class can have many students. I'm using classes like a school instructional session kind of thing. So you might have these 7 classes that you're in. Each of those classes has 30 students in them. So the join table on that would be an enrollment.
Movies and actors,
Yep,
car models, car manufacturers.
there you go.
Recipes and ingredients.
All of those are many-to-many relationships.
Kyle, in terms of the instance versus name,
Mhm.
the language, is this creating that set of numbers to keep track of the instance of dog?
This set of numbers here is technically the address in your computer, like where that data is being stored right now.
Okay.
But like when I made these don't have to be so similar. This could be K. This could be fart. I can change the name down the road from Kyle to Kylie. I can do whatever. Those two things don't directly have anything to do with each other. This variable name is just a label for how I'm storing it right now.
All right. But if you change that name right there, are you also changing that set of numbers? Are you creating a new instance?
So when I run this file, it goes, all right, I need pry. I go, cool, here's your pry code. I go, I need all the code from these 3 files. It goes, cool, just like you copy and pasted them in. And it goes, I want to create a new instance of owner. It goes, cool, allocating memory. I'm giving it this property, done. Then we do that 5 more times. All right, I want you to look up wherever you stored Kyle, and I want you to call the add dog method, and I want you to pass in whatever's stored at this memory address, and so on down. When I kill the program and run it again, it does all that all over again. If I changed my name, so like right now I can read it. I can also make it writable. So if I do something like that, all right, there's Kyle. I like that name. I always thought I should be the Hammer. Cool. The variable name is still Kyle. The memory address is still the same. Some property of the object changed.
Right. Name. Okay.
Did you do this without the join table? Like if you had an array in the owner class that pointed to all the dogs they owned, and if you had an array in the dog class that pointed to all the owners.
Ah, beautiful thought process. So yes, you could. You could absolutely solve the problem that way. Here's the problem. Now we have 2 sources of truth, and over time, those can start to disagree. Bixby could say that he's owned by Kyle, but Kyle could say that he doesn't own Bixby. So one of the core idea in programming as a whole is that we want to make illegal states unrepresentable, which is a fancy, pretentious way of saying like, if it's not possible, you shouldn't be able to code that. And so anytime we're storing the same fundamental piece of data in 2 different places, that's like a sweat should be dripping down your forehead moment. So by having that join table, we're only keeping track of this information in one place.
Is there an advantage to doing this in a way where you could ask the owner like what dogs they own, but you can't ask the dogs who their owners are?
Maybe. Like if that's not getting used in your application, don't code it. Code that just seems like it'd be nice to have that you throw in there is code that you have to maintain. It's like, well, we just added these streets because it would be neat if the whole city was a perfect grid. All right, well, nobody uses those streets. Like, yeah, well, we have them. Okay, well, now we have to have maintenance crews like maintaining them and stuff, and that costs like actual money. So it is with code. You don't want to maintain code that you're not using. So if you would never ask a dog who their owners are, then yeah, don't make a method for it. All that depends on what your application is.
So I suppose a dumb question. The class, when you define that, when you define owner,
Yeah.
what is that? Because I know the cat class will tell you, but
So,
array
not a
or
dumb question at all. This is a very tricky question. And in fact, I took a class in college called Object-Oriented Analysis and Design, which was all about classes and objects. And by the end of that roughly $4,000 class that I was in for 16 weeks, I could not tell you what a class or an object was. So, yay, higher ed. We'll talk about this in way more detail this week, but for right now, class is a cookie cutter and object is a cookie.
Okay.
So I've said that the shape of an owner is something that has a name and can add a dog and can list dogs.
Sure.
And an example of that would be Kyle. An example of that would be Elise.
Okay.
Could you review the necessity of being able to read it? That first, the attribute, either accessor or what, I forget what the other one was.
Reader.
Reader. There you
go. What about that?
Just like why it's necessary again?
Sure. So if you did anything with JavaScript in the pre-work, you're probably familiar with something like this. You make some object, and we do it like that. We also use the word object for something that isn't actually an object in JavaScript. And then you could do something like person.name and get back Kyle. You can't do that in Ruby. All you can do on Ruby is call methods. So if I do Kyle.addDog, that's not some freestanding thing that I can do whatever I want with. That's looking specifically for a method called addDog. Likewise, when I do Kyle.name, it's looking for a method called name, not a property called name. So the way that you would solve that is, all right, cool, I can make a method called name. I'll just have it return that variable. That's exactly what that does.
Okay.
The same thing. Because we have to do that so much that we have a shorthand for it.
And what is it called when you're when you do like dog owner dot owner? Is that chaining? So you're chaining the methods?
Yes.
Okay.
So you're whatever returns from the first one,
right,
which is presumably an object, and then calling whatever next method on that.
Okay. So that's what that syntax comes in.
Speaking of which, we can use that exact same idea to clean this up. So I did this as like these 4 different steps here. Doesn't have to be. I can say, ooh, dog owner dot all dot selects. That's more of that chaining. Gets even crazier. So I want to map. Snap. And if that's the thing that I'm returning, and it returns the last statement, well, this is the last statement. So I could really do that. Oh, but that's not all. We have 2 different syntaxes for these blocks, the things that start with do and end. I could also
the literal
those curly braces. Like that. And then that becomes that. Then we can do something like that. Holy smokes, we did it all in one line.
So you can tack these methods onto the ends of other methods, and it just implies an order of operations.
Yeah, it's whatever the first thing resolves to.
Yeah.
Do this on it.
That's fucking cool.
It is fucking cool, isn't it?
And I do feel dumb. You were right.
Cool. What else?
I just wanted to know like what the difference of that one at symbol and that double at symbol that you were using. I was kind of
Yeah.
curious.
So the one at symbol is called an instance variable. So I make a new instance of dog owner. That instance has a dog property and an owner property. The two ats is a class variable. So that's owned by dog owner itself, not any particular one dog owner. Basically, if it relates to more than one instance, it should be on the class. Because instances don't know anything about each other.
Gotcha. So when you make that at dog, that just becomes a property to that one unique instance.
Exactly.
But if you want to access that property, you have to have like some method of that, like the ATTR. Is that how you're trying to? Is that what I'm getting at? Okay.
Yes. And so with the double ats in particular, we don't have a shorthand like we do for adder reader. So we have to make a method on the class. So dog owner.all exists. Any one particular dog owner does not have an all method.
Gotcha. Okay.
And if you can wrap your head around that, that's everything you need to know about self. So if you were like really wrestling with this in JavaScript, shit, I'm still wrestling with this in JavaScript. There's 9 different things that this could mean in JavaScript. There's only 2 in Ruby, and they're very predictable. It's either the class or the instance. All right, high level, any other things? We did some basic programming in Ruby. We iterated over collections. That was the select and map. We're going to be talking about that more later today. Those lessons about enumerables, that's what those are. We've done some stuff with classes and objects. We modeled a problem. We didn't do any SQL. There's also not any SQL in your code challenge next week. We'll talk very briefly about that probably at the end of this week. Persisting data, that's related to the SQL thing. We modeled relationships with Ruby. That was our like add dog, add owner kind of stuff. And modeling relationships with active record we'll do during project week. That's the mod. What other questions?
So many. I don't even know where to start.
Your
Why
first
don't I
priority right now is like getting solid on these 2.
Okay.
Enumerables and like any like lingering basic Ruby stuff. That's like priority number 1 right now.
So when you're using that literal syntax literal, when you're chaining stuff, is there, I mean, obviously I'm sure that there is syntactically it can be incorrect.
Yes.
So it's always curly braces, block, and then that's
Not necessarily. And like, so every language has things that are naturally confusing in it, and every language has things that are naturally very clear in it. Ruby is very clear with things like self. Ruby is hyper unclear about things like syntax.
Yeah.
So the fact that it could be this or this, wrapping that in parentheses, and sometimes you need the parentheses and sometimes you don't need the parentheses.
Right.
That's naturally very confusing. And so like that's not a you thing. Every programmer struggles with this in Ruby. Because one of Ruby's design goals was to be very loosey-goosey on syntax so that programmers could write their code however they felt like writing their code. Python has the exact opposite value. Python's values are that every code should be written, should have one exact right way to write it.
Where do you come down on that?
Personally,
Yeah.
more towards the Python side. I'll admit that like a lot of the Ruby conventions have grown on me a lot over the years. But I don't feel like the freedom that Ruby offers with syntax is actually helps you write better software. I think it makes it harder to write better software because you end up arguing over syntax things that's not making the app any better. So there's a term for that in this industry. It's called bike shedding. And it comes from this apocryphal story about a nuclear power plant that they were designing. And so many considerations that you have to make when designing like the physical layout of a nuclear power plant. And the whole thing got bogged down arguing over what color the bike shed should be. And the reason why is because it's very difficult to form like a cogent opinion about a difficult design decision with a power plant. Very easy to have an opinion about what color the bike shed should be. And so that's what everybody got very strong opinions about immediately and started arguing with each other over. So it is with syntax.
Okay.
So does Ruby not have an equivalent to the kind of idea of like something being Pythonic?
Ruby doesn't, Rails does.
Gotcha.
Rails, like in a lot of ways, Rails fixes a lot of problems with Ruby. It's not a different language, it's built with Ruby, but there is a Rails style. There is not a Ruby style.
When will we get access to all of those resources under the mod? So I tried clicking on one and it said I didn't have access.
Cool. So you might have it already. If not, then Damon and I just fell asleep at the wheel on this. But one of the things that you often have to do is if you go to one of these labs, you have to go up to this curriculum thing and switch materials. If you're currently in the pre-work thing, you're not gonna be able to see any of this stuff. But you should see like a mod 1. You won't see a million of these like I do, but you should see like a module 1 thing with your cohort name under it.
Okay.
If you
I don't see that.
Okay, cool. Then Damon and I have to get those deployed.
Okay.
So we'll get on that right away. But everybody, you're going to have to go up to this curriculum area and switch materials. Otherwise, the thing that will happen is you'll click on these links and it'll just refresh the page. But we'll get that stuff deployed ASAP.
Okay. I was just wondering if I couldn't figure it out or if it was like everybody.
That's a very fair question. And also like, I'll try to get this video up pretty soon, but even if I don't for whatever reason, if you look up module in here, or maybe mod, or how about overview?
Mine's the same, Haley. I imagine that's for all of us.
Hey, there's a mod 1 overview. Hey, there's a mod 1 overview. Hey, there's another mod 1 overview. There's another mod 1 overview. Like almost everything we do probably has some video on it. So lots of different options. These mod overviews in particular tend to go about the same way most of the time. So you have these resources available. Awesome. So we're running a little bit long, so I'm going to stop it there. But you guys have How to Computer with Ahmed right now. I hope you enjoy it.
Thank you.
Cheers.